Okay, I think I've got it all set up. First off, before we get rocking and rolling, are there any questions? Hopefully you can hear me. There's a guy blowing leaves right behind my window. So if you want to ask me a question, speak up just a little bit. I'll turn my microphone up. But are there any questions about the homework from sections 3.1 or 3.2 before we get rocking and rolling today? Okay. I'll give everybody just a few more seconds. Okay, today it kind of feels like we're taking a left-hand turn by talking about dividing polynomials, but you'll see pretty quickly how this goes into the polynomial overall, or really what we're going to get to in the next section, 3.4, which is going to be solving polynomials. So for us to be able to solve them, we have to first be able to really divide out and get them factored completely. Okay, so the goal here when we're dividing these, eventually it's going to be to just factor completely. We're not going to start there though. We're just going to talk about how to divide. Now there's two ways to divide polynomials. There's a long division way and there's synthetic. We are going to stick to synthetic. If you would like to know how to do long division of polynomials, you're more than welcome to get on the internet and Google it and search for it. You'll see it's not necessarily that it takes any longer or shorter amount of time to do. It's just two different things, two different methods that accomplish the same result. So I'm not going to do that when synthetic division works perfectly fine, and it is a little more efficient than long division. Okay, so I'm not too worried about, actually I'm not worried about it all. You learning long division of polynomials, we are going to stick to synthetic division. So how do we synthetically divide and where does it really come from? Well, first off, I want to go back and talk about some really basic kind of division. And I'm talking way back, third or fourth grade when you learned how to divide back then, because we're going to use the same words for these concepts. And so it won't hurt us to have a little bit of review. First off, if I wanted to divide, let's say something that divides evenly. Let's say 32 divided by 8. Well, actually, the way we wrote it at the very beginning when we were learning was 32 divided by 8, right? We wrote it with this division symbol, which that division symbol actually comes from the fraction. It symbolizes a fraction. See the line with the dot on top and bottom. And that first number is the top and the bottom number, of course, is the bottom. That's how we wrote it at first. And then later on in like 5th or 6th grade, you started writing it as a fraction, 32 over 8. And then you did the operation. So now the way a lot of us learned this back then was, the old school way of dividing, where we wrote, how many times does 8 go into 32, right? I should have chose a bigger number. That's fine. We'll do a bigger number here in a minute. But what this is, so this is, let's actually get some terms going on. The number underneath here is called the dividend, because you're dividing it into it, the dividend. And then the 8 here is called the divisor. Okay, so we've got the dividend and we have the divisor. These are going to be the same words we use when we get to polynomials. And you just asked yourself back then, how many times does 8 go into 32? And you say, oh, it goes in 4 times, right? And you put the number above this and then you multiplied it and then you subtracted it underneath. 8 times 4 is 32. You wind up with 0, right? Now this, whatever you wound up here, was called your remainder. Okay? And then the number up here is actually called our quotient. That's what we were looking for. Okay? That's called your quotient. And we're going to use all of these words today, okay? But with polynomials. So all of these words are going to get used just with polynomials. And so what we actually found was that 32 divided by 8 just equals 4. Now, what's going to help us in the next section, actually later in this section and the next section, is that because we had a remainder of 0, it means that 4 and 8 are factors of 32. I'm going to repeat myself here. Because we have a remainder of 0, it means that 4 and 8 are factors of 32. So if you go back to this little equation that we just found, we can multiply the 8 to the other side, and we know that 32 equals 8 times 4. We have factored in a way. Now, we haven't factored it completely, but we do know that 8 and 4 are factors of this 32. You multiply them together, and you get 32. Okay? So let's look at something maybe that doesn't work out when you divide. Let's say we were looking at 426. Let's say 422 divided by 3. Okay? 422 divided by 3. I don't think this will divide evenly. And again, we can write it as 422 divided by 3. Guys, that leaf blower is pretty aggressive. I don't know if you can hear it on your side. I'm going to divide it the same way we've done before. So how many times does 3 go into 422? Well, 3 goes into 4 once, right? Put the 3 under here. It's a 1. We bring down the 2. This goes in 4 times. 4 times 3 is 12. 0. We can bring down the 2 now. 3 doesn't go into 2. So you'd actually write a 0, 0, and you're actually left with a 2 remainder. And so I want to go over what this means. Now, look, synthetic division is not going to look like this. So if you don't remember how to divide, I don't care. You can use a calculator, whatever. But I've got to talk about what happens when we have this. Now, so this is our remainder, right? We'll call it R. We've got our dividend. And we've got our quotient. I'm sorry, our divisor. This is still considered our quotient. Okay? And back in like 3rd or 4th grade, when you learned how to divide, you said that, 422 divided by 3 is 140 R2, right? That was how you first learned it. And then later on, though, what you found was that actually 422 divided by 3 is our quotient plus your remainder over your divisor, okay? These mean the same thing for this example, but we're going to write it in this form. So if we wind up with a remainder, we're going to write it like this. You write your quotient plus your remainder over your divisor, okay? Quotient plus your remainder of your divisor. Your book goes over this too. It's not like this is something I'm talking about. But now here's what happens. Because we have a remainder here that's not 0, it's 2, it turns out 3 and 140 are not factors of 422, okay? So because we have a remainder that's not 0, it tells us that these two numbers are not are not factors of the dividend, okay, of the 422. That's really what's important for us moving forward into the end of this section and actually the next section. Okay. Any questions about this before I go into how to synthetically divide a polynomial? Great. Okay, so let's get into the actual steps. Actually, piece of paper underneath here. I don't need to waste it. How to synthetically divide this. I'm going to kind of get this screwed up just a little bit so you can see the whole paper. There we go. Yeah. Okay. How to synthetically divide? Well, synthetic division is going to do the same kind of thing that we just saw, but it does in kind of one step. And there's a few rules with synthetic division. So let's see what I'm talking about. Well, let me find a good example here. Yeah, let's say we had 7 minus 11. Actually, let's do one that works. Hold on. Let's do one that actually divides evenly so I can kind of show you. Well, I thought that would be easier to find. Hold on, guys. I can just make one up. Yeah, I'll just make one up. So let's say we had 10x plus x squared plus 21, and I want to divide it by 3 plus x. Okay, 10x plus x squared plus 21, and I want to divide this by 3 plus x. Now, here's the first thing. If we're going to do synthetic division, excuse me, if we're going to do synthetic division, we're going to write these descending with missing terms, okay? So what that means is like this first, this is actually our dividend, right? This dividend, we're going to have to write in descending order. So x squared has to come first, plus 10x, plus 21. So descendingly, right? Squared x constant. And then the same thing with the divisor here. We've got to write that in descending order. So the x comes first, plus 3. Okay, so before you do synthetic division, you have to have each polynomial written in descending order with missing terms. Now, there's no missing terms here. I'll do an example of that probably in the next one. Okay, how to handle that. Now, what we're actually going to do here, we're going to pull out the coefficients. So if you think about this, I'm going to write the 1 here because it's a coefficient. The coefficient of the dividend is going to be, or the coefficients, I should say, of the dividend are 1, 10, and 21. So I'm going to draw a little like kind of L shape. And I'm going to write 1, 10, and 21. I'm going to write those kind of individually right here. 1, 10, and 21. Okay. And this really is one of those things that feels like I'm waving a magic wand and poof, I've got the answer. Okay. But just roll with me for a minute. Now look, if x plus 3 is your divisor, I kind of need you to think of it as if it was a factor. Remember, if we had, I'm going to pause here for a minute. I'm going to look at some other example. If I said g of x equals x plus 4 times x minus 1, right? And I ask you, hey, what are the x-intercepts? It was kind of nice in this form, because remember with x-intercepts, you set the whole thing equal to 0. So x plus 4 times x minus 1 equals 0. So I'm going on a little tangent here. I'll come back to synthetic here in a second. But so if we had a quadratic in factored form, and I ask you for the x-intercepts, it was nice when it was factored because you set each factor equal to 0, and then you solve them. So x plus 4 equals 0, well, you subtract the 4, and you wind up with x equals negative 4, right? X minus 1 equals 0, you add the 1, and you wind up with x equals a positive 1, right? X equals a positive 1. So here's where these were our two solutions there, or two intercepts in a way. Now, look, over here, we're really testing to see if this divisor is a factor of this dividend. But look, if it is a factor, so if it winds up being something like this, then the solution that comes from it has an opposite sign as inside of the factor. So, x plus 4 here, the solution winds up being negative 4, right? X minus 1, the solution is a positive 1. Okay, so what we're actually testing is this x plus 3. We're testing to see if the negative 3 is a 0 of this function. That's really what we're doing. This is why this was developed. So I know that was a very long story just to tell you, hey, whatever's here, the plus 3 or the whatever number is here, you've got to use the opposite over here. And it comes from this aspect where, if x plus 4 is the factor, then minus 4 is the solution. Okay, so the solution actually goes there. Okay, so, also this variable has to be by itself. It has to be just an x. It cannot be like 2x, 4x, negative 8x. It has to be x. I'll get an example on how to deal with it if it's not just x, but it has to be just an x. Okay, It can't be x squared. It can't be x cubed. It's got to be x plus a number or x minus a number. Okay. Back to the question at hand. How do we do synthetic division? So we put the coefficients from our quadratic here, and then we put the opposite number of our divisor here. And so here's the steps. I'm going to go slow this first time, probably the first few times. And after a while, you'll get the pattern down, and it actually doesn't take long at all. So the first thing you have to do, whatever this first number is, you bring it down below the line. Okay, so you bring it down and you write it below the line. Then once it's below the line, you always multiply it by the potential zero there. So 1 times -3, whatever I get for that multiplication, I'm going to write it right here. Okay, so 1 times -3, oh, that's just -3. Okay. And then you're going to add vertically. Okay, add vertically. 10 plus a -3, oh, that's a +7, right? And then whenever it goes below the line, you're going to multiply it by the potential zero. So 7 times -3, well, that's -21. And then you're going to add vertically. Well, 21 plus a -21, that's 0. Now I'm going to box that number in because it's probably the most crucial of all the numbers. This is your remainder. Okay, that's your remainder. This tells us everything I need to know about this factor being a factor, actually this divisor, I should say, being a factor of this quadratic. So because we have a remainder of 0, this means x plus 3 is a factor of x squared plus 10x plus 21. That's awesome. Okay, that's great. But let's see what we actually found, the quotient. Now the quotient is hidden right here, 1 and that 7. That's the quotient. And what you actually do is you go from the 0, so the 0 is always a number. This is going to be your constant. The column next to the remainder is your constant. And this is going to be your x value. If it kept going, this would be your x squared. The next column would be your x cubed. We'll get to something like that here in a minute. But so your quotient is actually underneath this line is where your quotient is. So it turns out our quotient is going to be 1x plus 7. Okay, 1x plus 7. So I'm going to rewrite what the solution is actually. So we have found that x squared plus 10x plus 21 divided by x plus 3 equals x plus 7. That's what we found. Okay, so x plus 7 is our quotient. Okay, and I know that was a lot, and we're going to see a lot of different examples here coming up on these. But before we just see more examples, do you guys have any questions about this process? Other than, okay, I just need to see a few examples. Okay, now what's nice about this one, no remainder. So what this also means, because these two are factors, what we have also found, which is really going to be what's important for the end of this section and for tomorrow, for Wednesday, I guess, is that x squared plus 10x plus 21 equals x plus 7 times x plus 3. We factored this dividend, okay? We factored the dividend, kind of neat, okay? Really neat, actually. That's what's important. That's what's important really moving forward. We've got to know the process, though, to get there. Okay, so let's look at another one. And I'm going to do one that doesn't factor, just to show you that, I'll tell you up front, this is going to have a remainder, okay? This is going to have a remainder. So let me find one. Excuse me. Let's do x cubed. Actually, let's do 5x plus x cubed plus 4x squared plus 5. And I want to divide this by x minus 3. Okay, I want to divide this by x minus 3. And before I can even get started, I have to write this in descending order. Because when you write that synthetic kind of L bracket, it has to be written in descending order as we go down. So I'm going to say this is x cubed plus 4x squared plus 5x plus 5. Now we're still dividing it by x minus 3. Okay, so let's work this one. Now I'm going to make my L bracket. Ooh, let me put that on silent. And I've got x minus 3. Now remember, we're really testing to see if this is a solution. And if x minus 3 is the factor, positive 3 is going to be the solution. Okay, positive 3 is going to be the solution. And then I'm going to write the coefficients of the dividend descendingly. Okay, so 1x cubed. Notice there's no x's here. Okay, it's just 1. 4x squared, 5x, and 5. Okay, so we have set up synthetic division correctly, I think. Yeah, we have. Looks right. Now I've got to just divide it. So I've got to do the operation. So again, no matter what number is there, we're going to bring it straight down. And then once it's under the line, we're going to multiply it by the potential 0. So 1 times 3, 3. Okay. Remember, once it's here, we're going to add vertically. 4 plus 3 is 7. Okay. Then multiply 7 times 3 is 21. Right? Oh, we're going to get a big number. Add vertically, we get 26, right? 26 times 3. Let me see here. I don't have enough fingers and toes for that one. So I'm going to multiply that in my calculator. 26 times 3, 78. Add vertically, that's going to be 83. Now look, this is our remainder. So that tells me that x minus 3, not a factor of this, not quadratic, but third degree polynomial, right? This is not a factor of this third degree polynomial. So that's kind of a bummer. And in the next section, we're actually going to kind of stop here if it's not a factor, but we're going to clean this up because it actually just asked us to divide. So what we found though is there's our remainder. And remember, right here's our quotient. So what we found is that x cubed plus 4x squared plus 5x plus 5 divided by x minus 3 actually equals, now look, here's our remainder, here's our constant, here's our x term, this is going to be our x squared term, okay? And look, it's not a coincidence. When you take a third degree polynomial and you divide it by a first degree polynomial, you're going to wind up with a second degree polynomial. You're subtracting actually, 3 minus 1. So constant x, first degree x, second degree x. So this winds up being 1x squared plus 7x, there's our 1x squared, plus 7x plus 26. Now we're going to write this in that fraction way. So we're going to write it as our remainder over our divisor, x minus 3. And this is actually our solution. Now look, to make the 1 go away, I'll just make it part of my box. That was pretty smooth, I know. And boom, there we have our quotient. So this is our actual quotient. The way it's going to be written as a solution, okay? Or not solution, but the way it's going to be written like on a test, what it'll look like. Okay, now look, this doesn't help us out at all. This means that x minus 3 is not a factor that's bigger. It actually means this isn't a factor either. If you've got a remainder, of course you don't have a factor, right? That's not a factor because there's a remainder. So any questions now? We've done one that works and we've done one that doesn't work. But for now, we're just trying to get how to divide these out. That's really the first topic. How do you divide? Well, you set it in descending order, put the potential 0 there, descending coefficients for the dividend, and then do the operation. This tells us our coefficients of our quotient, 1x squared, 7x, 26. And that last number on the right is always the remainder. Okay, always the remainder. So any questions before I choose another one? Great. Okay. So let's see. Let me do one that actually has the missing zeros here. So what if we had 5x squared plus 6x plus 8, and we want to divide it by x plus 2? Oh, I'm sorry, that's not 5x squared. That's 5x cubed. So 5x cubed plus 6x plus 8. And we want to divide it by x plus 2. Now here's the thing. We have a missing term here. Since this is a cubed and this is an x, now it's descending, right? There's no x squared term. And if we use synthetic division, we have to have a spot for that squared term. So you need to think of this as 5x cubed plus 0x squared plus 6x plus 8 divided by x plus 2. So this is descending with a missing term, okay? And then when we set up our division, which I want you to do this one completely this time, but when we set up our division, now look, plus 2 over here, so I'm going to write minus 2. And then my coefficients have to include the missing term. So 5, 0, 6, and 8. So I want you to divide this one, find the quotient, find out if it's factorable or factor, if x plus 2 is a factor. So I want you to work on this one, complete it out. I'll give you about a minute, 2 minutes. You don't have to be completely done when we start rocking or looking at it. Okay, let's see. Let's see here. See if we get this one. So I got to bring the 5 down. If it goes a lot below the line, you got to multiply it by the potential 0 here. 5 times -2, that's a -10. Add, we get -10. -10 times -2, that's a +20. Yeah, this does not look like it's going to wind up being 0. 26 times -2, that's going to be a -52, I believe. Add that vertically, and you're going to get 40, what's that, 44? Yeah. So yeah, no, this does not divide. X plus 2 is not a factor of this polynomial, right? And the reason I know that is because we have a remainder here. So, but it winds up, the answer, the quotient really winds up being, now look, so remainder, constant x squared. So 5x squared minus 10x plus 26 plus, now you can say minus if you want and put 44 here. I'm going to put plus and then negative 44 over x plus 2. Either one of those is fine. If you want to say, well, it's minus 44 over x plus 2, you're not wrong. But that's our actual quotient. That's what we're looking for. Okay. Questions, comments, concerns on this beautiful Monday afternoon? Are we getting it? Or we think we're getting it? Let's look at, let me give you a few to try on your own, just to make sure that we understand it. And of course, I'll come back behind and work these. And I'm going to steal them straight from your homework. These will just be evens from your homework. So if you flip over to like page 373, it starts on that. Notice they asked about long division first. So let's start with the synthetic division on the next page. So let's do.
Are we going to have any of the long division ones for homework?
No, unless they work out well. Like, okay, yeah, I'm going to do one for homework or for this one here in a second, because it's just a different kind of example, but not necessarily.
Okay.
And I'll tell you why. If you're looking at the long division, notice like number 7. Number 7 says 12x squared plus x minus 4 divided by 3x minus 2. Well, that can't be done the way it's written in synthetic form. So I've got to go. I'll show you how to do it in synthetic form, but it's just, and we won't need it for later on. So that's why I'm not worried about it.
Okay.
But how about this? We can do number 4 that way. So I want you to do synthetic division. So this is number 4. Do it synthetically, even though it says not to. It says to do it long division. X cubed minus 2x squared minus 5x plus 6 divided by x minus 3. So let's do that one. And then let me choose a trickier one here. Oh, Lord. Yeah, let's try 28. That was crazy. That one won't be bad. So let's do 28. I'm going to leave a little more room on my paper for 28. 28 is x to the 7th plus x to the 5th minus 10x cubed plus 12 all over x plus 2. So let's try those two, and I'll give you a little bit of time, especially that second one. Give you a little bit of time on that. Okay, let's see if we got it right. See if we get this process down. That's what matters. And then really, it'll be adding on what we really need to understand about factors and factoring. Okay, so we've got this third degree polynomial. The potential zero really would be 3, right? And it's already in descending order, which is nice. There's no missing terms, unlike down here, right? Down here, we don't have an x to the 6th, an x to the 4th, an x squared, or an x. There's going to be a lot of zeros here. But up here, we've got 1, -2, -5, and +6. So we bring down the 1, multiply it, add that together, we get a 1. Multiply it again, just 3. Add that together, we get a -2, right? We multiply that, we get -6. Say, hey, we get a 0, right? Now look, I'll tell you. If I get a 0, I really am thinking happy thoughts, because it tells me that x minus 3 is a factor. And what that's about to mean that I haven't really gone over yet is that if x minus 3 is a factor, 3 is going to be a solution. It's going to be a root, a 0, however you want to call it. Remember, your book calls it 3 different things. But 3 is going to be a solution. So because this is 0, it tells us a lot about this polynomial, actually. But for this section, we're just saying, well, what does this actually equal? The quotient then, though, remember the quotient is right here. So it's a -2, a 1x, and a 1x squared. So x squared plus x minus 2. No remainder, so we don't have to do like plus remainder over divisor. Okay. Any questions about that one? Before I go, the next one's going to be long and kind of treacherous. I might have to get the calculator out again. Let's see here. So it's written in descending order. There's just no zeros. So if I've got to write it with missing terms. So x to the 7th plus, there's no x to the 6th, plus x to the 5th, plus there's no x to the 4th, minus 10x cubed. There's no x squareds. There's no x's, but there's a constant. And even if there wasn't a constant, you'd have to put this here, guys, okay? Holy cow, 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 terms if you include the missing terms. Now I'm really dividing this by x plus 2. So this would be -2, could be our solution. We don't know, we're really checking it. Holy cow, 1, 0, 1, 0, -10, 0, 0, 12. Okay. And then I'm going to go through, I'm going to be just very careful because I know I like to speed through these, and that's not good. I've got to be very careful and just make sure, kind of meticulous as I go through it. So bring down the 1, multiply it, I get -2. Add, I get -2 because anything time, plus 0 is itself. Multiply, I get a +4. Add, I get a +5. Multiply, I get a -10. Add, I get a -10. Multiply, I get a +20, right? Add, I get a +10. Multiply this, I get a -20. Add, I get -20. Multiply it, I get a +40. Add, it's a 0. Multiply this, I get -80. Add this, I believe it would be -68, which is no good. This is still our remainder, okay? But this is no good because this is not a remainder of 0. So it tells me that x plus 2, not a factor of this 7th degree polynomial. What this also tells me is that -2 is not a solution, right? It's not a root. It's not a solution of that polynomial. But I have to write out what the quotient. So what we found, actually, this is equal to, I'll put it down here. Now look, this is our remainder. So constant x squared, x cubed, x to the 4th, x to the 5th, x to the 6th, which makes sense because it was a 7th degree polynomial divided by a 1st degree. So it's going to leave me with a 6th degree. So 1x to the 6th minus 2x to the 5th plus 5x to the 4th, right? 6, 5, 4, minus 10x cubed plus 10x squared minus 20x plus 40 plus negative 68 over x plus 2. Holy cow. That is our quotient. Okay? That's our quotient. Are there any questions about this before we go on really to the next concept? Any questions about this before we go to the next concept? Okay. Well, the next concept your book goes over is called the remainder theorem. And it's not that it helps us out too much, but it's kind of interesting. So if we have a polynomial, let's say f of x, and we divide f of x by x minus c, where c is some constant, turns out the remainder is always f of c. It's kind of neat. And actually, I'm going to do this one with the example we just looked at, actually, with this example 28, okay? Let's say this was actually a function. We'll call it f of x. X to the 7th plus x to the 5th minus 10x cubed plus 12. So we're going to call that a function. So instead of it being a dividend right now, it's just a function. So we've got this function, and we want to divide this function, divide f of x by x plus 2, okay? Now that's really our x minus c here, okay? And what you can do actually is in this x plus 2, just like we've been doing with the synthetic division, you're going to change the sign of the plus 2. That's why it's a minus there. So you're going to change that, and that c value is actually going to be negative 2. So we're going to plug in negative 2, and it comes from right there. If you plug in negative 2 to this function, so negative 2 to the 7th plus negative 2 to the 5th minus 10 times negative 2 cubed plus 12. If you plug that in, we're actually going to come, it should come to our remainder. Now, I remember when we did all this work, our remainder was negative 68, right? So it should come out to be negative 68. Let's see if that's true. 2 to the 7th. Oh, 128 maybe? I don't know. Hold on, let's see. Clear. 2 to the 7th. Yeah, 128. Now we're multiplying it an odd amount of times, so it's going to be negative. So negative 128. 2 to the 5th I know is 32. So minus 32. Is this going to work out? 2 to the 3rd is, or negative 2 to the 3rd is negative 8 times a negative 10. So that's a positive 80 plus 12. So I'm going to add all those together. So we've got negative 128. Minus 32 plus 80 plus 12. Yep, negative 68.
Could you just explain real quick how you got the negative 2 again if we were dividing f of x by x plus 2?
Yeah, look, just like whenever we divided it with the synthetic division, x plus 2, we would write negative 2 up there. It's the same thing. So when you divide by x minus c, you're really, it's that negative sign means you're changing the sign of the c. That's all it means.
Gotcha.
Yeah. And I'm telling you, this is called, I didn't write down what this is called. It's called the remainder theorem. Remainder theorem. And it's not that it's that big of a deal. We'll see technology kind of helps us out a little more than the remainder theorem, but it's out there. Okay, it's something we can use to see if we have a solution or not. Because really what this tells us is that negative 2 here, negative 2 is not a solution of this polynomial because we didn't get back 0, right? We didn't get back 0. So it's not a solution of the polynomial. And that's where it can kind of help us. If we got back 0, we know that -2 is in fact a solution. And that's kind of what the next part says. If you look on page 372, so we've got the remainder theorem, and then we have the factor theorem. So the factor theorem says, again, if we've got f of x, if f of c equals 0, then x minus c is a factor of f of x, which we know that. I've kind of said it 20 times so far in this lecture. And then vice versa. So vice versa. There's two statements here. If x minus c is a factor, then f of c equals 0. So that's just vice versa statement, okay? So if it winds up being 0, then we know x minus c is a factor of that function. And that would happen if we do, I'll do another one here, I guess. If we look back at, let me kind of leave that one up here. If we look at that last example, like if we said f of x equals x cubed minus 2x squared minus 5x plus 6, and we want to divide f of x by x minus 3. Now we did this. This was that example right before the one above it. If we want to divide it by x minus 3, well, now it's x minus 3, so I'm going to plug positive 3 into the function. And when you do this, you should get back 0. So 3 cubed minus 2 times 3 squared minus 5 times 3 plus 6. 3 cubes, 27. 3 squared is 9 times a -2, so that's -18 minus 15 plus 6. 27 minus 18 minus 15 plus 6 equals 0. Okay, so f of 3 winds up being 0. So what that means is this function, x minus 3, is a factor of this function. And what it also means is x equals 3 is a solution. Okay, x equals 3 is a solution because we got back a remainder of 0. Okay, we got back a remainder of 0, so that's kind of nice.
Thank you.
Yeah, no problem. So yeah, those are two good examples of the remainder theorem and the factor theorem. They're kind of the same thing, just kind of mushed together. But let's look and see what this leads to. And I do like the fact that your book does this. What we're getting to is actually solving for all the solutions of these functions. Okay, that's the goal. I gotta get some more paper. Give me 2 seconds. We've got to find all the zeros, okay, all the solutions. Remember, these are all kind of used together. And I'm going to steal this one straight from the book. Actually, I bet I can find an example of it. Yeah, this is example 6. And I'm going to steal it straight from the book. I don't think it gives us one that isn't. Wait, here
What page is that?
Oh, hold on. I'm gonna steal one that's actually not written that way. So it's on page 373 actually. If you look on page 373, it talks about checkpoint 6. Solve the equation. Oh, I'm over here. Solve 15x cubed plus 14x squared minus 3x minus 2 equals 0. So it wants us to solve this. Now it gives us a hint. Given -1 is a 0. So x equals -1 is a 0. Okay? Now it writes this as a function. F of x equals 15x cubed plus 14x squared minus 3x minus 2. So this is our hint, okay? We've got this solution. I'm sorry, we got this equation. And it says, look, solve this given we know that -1 is a 0 of this function. And I really need you to pay attention because every single question that we're going to do for the rest of this section and tomorrow or on Wednesday in 3.4 kind of starts here. The basis is here and we springboard to everything else. So I'm going to slow it down. I'm going to gear it down. And I'm going to kind of go over why this is true, how it's true, and yada, 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 okay? But look, let's start with this actual function or equation. Look, there's 3. The degree is 3. So what that tells me is I have 3 solutions. I can't use a quadratic formula here, right? Quadratic formula won't work. I can't just pop this puppy in the quadratic formula and give me the solutions. That quadratic formula only gives me 2 solutions because it comes from a quadratic that's a degree of 2. But what I can try to do is pop out factors from this 3rd degree. So think about this. If I could take a single factor out of this 3rd degree, if I pop a factor out, it's going to leave me with a 2nd degree. That's what we're about to do. Okay, so if that doesn't make sense to you, that's fine. Just buckle up and watch me. Okay, but what I'm going to do is I'm going to take a factor out and it's going to leave me with a 2nd degree polynomial. A 2nd degree polynomial I can solve. We spent a whole section at the very beginning of this class, section 1.5, on how to solve quadratics, right? So I'm comfortable solving this if it was written without this cube, right? I mean, 14x squared minus 3x minus 2. Hey, I popped that into quadratic. I'm done. Okay. I'm comfortable with these. I am not comfortable with 15x cubed for now. So let me actually show you the first step here. So given x equals -1 is a 0 of this function, I'm going to actually solve for all 3 solutions here. And where I have to start is synthetic division. Okay. What I'm actually doing here is taking 15x cubed plus 14x squared minus 3x minus 2. Because -1 is a solution, I'm going to divide it by x plus 1. Okay? I'm going to divide it by x plus 1. Now, look, you don't have to write this down, but I wanted to show you where it's coming from and how it relates to what we've been doing for the last hour.
Yeah, I get that.
Okay, so I'm going to write this synthetically. Remember, what really goes here is our potential 0. Now, what's nice about this question, it's not a potential 0. It told us -1 is a 0. That's great that it told us that -1 is a 0. We've got to know what the quotient is, though, to solve this out. Okay, so even though this isn't really potential anymore, it is. We're going to put that right there, that -1, like x plus 1. Is the factor, -1 is the solution. And then I'm going to write out the coefficients. Okay. And then I'm going to do what we've been doing for the last 40 minutes. And I'm just going to actually divide this out. So I'm going to bring down the 15, multiply it. So -15, right? Add it, I get a -1. Multiply it, I get a +1. Add it, I get a -2. Multiply it, I get a +2. Add this, and I'll wind up with 0, which is exactly what we should wind up with, right? We knew that -1 is a solution. And because we knew it was a solution already, that was the hint, right? Then we knew that this remainder had to be 0 once we divided it out of the polynomial, okay?
Mm-hmm.
Chastity, do you have a question? Your mic's on. I just wanted to make sure.
Nope, I'm just listening, making sure I can.
That's fine. That's fine. I want to make sure.
I'm totally getting it.
That's good. Well, hold on. Sit tight.
Oh,
No, and it's not that it gets harder. It just, we keep adding kind of parts to it. But here's what I need you to realize. Look, what we found here is that this division actually equals, what, 15? Now remember, this is a quadratic. constant x squared. So 15x squared minus x minus 2, right? 15x squared minus x minus 2. But for us, what matters is that we have factored this third degree polynomial. We know now that f of x is actually this. Remember, if we had a remainder of 0, it meant that the divisor and the quotient were both factors. And I'm going to write this accordingly. I'm going to write the quotient first. Actually, I'm going to write the divisor first. X plus 1 is a factor. We know that because negative 1 is a solution. Times what we found, 15x squared minus x minus 2. Okay?
Mhm.
Questions about this? So look, we found that this third degree polynomial, we've actually factored it, right? We factored it. Remember I told you what we're going to do is we're going to pop out a factor, x plus 1, and we're going to be left with a second degree polynomial. And look, guys, I don't know if any of you watch New Girl or if it's even still on with Zooey Deschanel. I got into it one summer, whatever. But one of the things in that show is they talk about, I forgot the game that they play, but it's where the floor is lava and we've got a safety couch. This quadratic is our safety couch. We know how to solve that thing, okay? We can use the quadratic formula, we can factor it, whatever. A quadratic is our safety couch. And what we did is a third degree polynomial is not our safety couch. We divided out a factor and we're left with, since we got a remainder of 0, it pops out and then it leaves us with our quotient, which for this example turns out to be the quadratic, which is our safety couch. Okay? So I'm going to factor this because I think these are factorable. You got to use the AC method. If you want to just use the quadratic formula in your calculator, you're more than welcome to do that. But I believe this is factorable. 15x squared minus x minus 2. So you multiply, you get negative 30. Negative 6 and 5 adds up to the negative x. So you break it apart. That together. I can factor out a 3 here. Leaves me with 5x minus 2. Actually, 3x. And then I can factor a 1 out. I don't want to change it. So this winds up being 5x minus 2 times 3x plus 1. So this actually factors into those two factors. If you do that, this was the AC method, right? We talked about earlier in this class. So x plus 2 or x plus 1, these two factored into 5x minus 2, 3x plus 1. Hey. Look, again, I think we've talked about this. 3 factors. Third degree polynomial. We're about to have 3 solutions. That's not a coincidence at all. We can graph this too. Probably just wind up doing that. Why not? But look, if I want to know the solutions, remember you put each one of those equal to 0. Solve it. X equals negative 1. We knew that one already. It was nice of them to give that to us. 5x minus 2 equals 0. Well, if you solve this, you add the 2, divide the 5. So you get 2/5. 3x plus 1 equals 0. Subtract the 1, divide the 3. You wind up with negative 1/3. There's our 3 solutions. Those are our other 2 solutions, right? If you look back, the question asked, solve the equation blank, given that negative 1 is a 0. So the 3 solutions are given. Negative 1, 2/5, and negative 1/3. Okay.
So those would be y-intercepts on a graph, correct?
Not y-intercepts.
Or x-intercepts, I'm sorry.
X-intercepts. Yeah, let's do a quick sketch of this if we want to. Look,
I just wanted to be sure I was right by thinking that.
No, you are totally right. And let's do a quick sketch of this just for fun because it brings in the concept from the last section. So notice none of these repeated, so we know we're going to go through the x-intercept or the x-axis. And we only go from negative 1 to negative or to positive 2/5. That's like 0.4, right? So we'll do big jumps. So the furthest left would be -1. And then we're at -1/3. That's about there. And then 2/5 is about right there. And look, this is our polynomial, right? It's cubic, so I know it's opposite. 15 positive leading coefficient. So I know that this is going to go this way. And because it's an odd degree, it's going to be opposite, right? And then each one of these only happens once, so we go 3. Probably does something like this goes up. Actually, it's going to be very dramatic how it goes up. Something like that. Something like that. It's not perfect, but our graph looks something like this. This is F, okay? To bring in old stuff. That's a lot. And actually, you don't have to write as much as I did, okay? This is me explaining every little concept. On the next one, I won't probably use as much, put as much information for this next example. But any questions about that one? This is like the easiest one we're going to do, really. And when you do the homework, like in the next section and come back to this one, you go, oh, wow, yeah, that was easy. Okay. This will be one of the easier ones we do, but I need you to ask questions if it's not clicking. Okay. So let's try another one. And I like this one because it kind of gives it to us in a different way, and it gives it to us as a fraction. So this is number 46 in the book. It's on page 374. And it says 3x cubed plus 7x squared minus 22x minus 8 equals 0. Now, okay, it says solve this. Solve this given x equals -1/3 is a root. And now, remember I told you last class that Dr. Blitzer, root, solution, 0, they really all technically mean something a little different, but they're all found the same way, okay? They're all found the same way. It's just finding zeros. It's finding solutions to this graph, okay? I say to this graph, to this equation. Now, the first thing I'm going to do, I like thinking of this as a function. Now, 0's got to be on one side of it if you're going to do that. And I didn't mention that before. So I'm going to think of this as our function, f of x. And again, I've got a third degree. I need to factor out something to leave me with a quadratic. And thankfully, it tells us a solution. So instead of writing this out, I'm going to go right to the synthetic division. I'm going to go right to the synthetic division. -1/3 is the solution. So that's what I'm going to write there, right? It's not in factored form. It's already in the solution form. So because it's the solution, it goes here. And then I'm going to write, these are all there, so descendingly. Write this, the coefficients descendingly. Okay. And then I'm going to factor this thing. Now, look, this should give me a remainder of 0 because it tells me that this is a root. It's a solution. If I don't get a 0 here, I did the math wrong. Okay. So you need to go back and check it, because if you don't get a 0 here, we definitely did the math wrong. So we bring down the 3. 3 times -1/3, that's just -1. Add it vertically, we get 6. 6 times -1/3, that's -2. Add vertically, we get a -24. Multiply that, so a third of 24 is what, 8? Now 2 negatives make positive. Hey, hey. Happy face emoji, right? This is a good thing. We got a remainder of 0. We were supposed to because it was the root, okay? We got a remainder of 0. We're on the right path. It's all good. Okay. But I'm going to write now what we found, actually. So what we found is that f of x equals this third degree polynomial I know can be written as a factored polynomial. Now look, if -1/3 is the solution, x plus 1/3 is the factor, right? Remember, these were opposite. times, now this is a little quadratic, right? 3x squared plus 6x minus 24. Okay. Any questions? I kind of went a little faster on that one because we've already seen this before, but are there any questions about that?
Why did the 1/3 change to a positive again?
Okay, now remember, then if it's a solution, it was a solution up here, right? So if it's a solution, you would write it in factored form like this. I'm going to bring back an old one here, up here. Remember, look, here's the solution, but then when we wrote it, it was in factored form, it was x plus 1.
Oh, right. Okay.
Okay.
Got it.
So it's going to be just opposite that way. Okay.
Okay.
And think about it too. If you set this equal to 0, x plus 1/3 equal to 0, you subtract it to the other side, right? And you wind up with x equals negative 1/3 as the solution.
Okay. I guess I just thought about it differently because it's a fraction.
Yeah. Don't let the fraction fool you, right? Don't let the fraction throw you off. Now, okay, we've got to find the other two solutions though, right? We've got 2 more solutions going on here. And we have to solve this polynomial. So I'm going to see if I can just factor it. Well, look, I see that all 3 of these have a factor of 3, right? So I'm going to be a little lazy here. I'm going to factor a 3 out of here. And I'm going to put it out front because that's what we typically do. And this would be x squared plus 2x minus 8. Yeah. So since all 3 of them were divisible by 3, I can factor a 3 out. Now you could write it in between here. It's all multiplication, but it makes more sense for constants just to go to the very front. Okay. And then now all I have to do is factor this trinomial, which is an easy trinomial to factor. This is just what x plus 4, x minus 2. Okay. Yeah. Now check this out. We have our 3 factors with x's. Those 3 have x's. That's our first 3. We have a 3rd degree polynomial. That's our second 3. And this is going to pop out 3 solutions, right? We know x equals negative 1/3 from the first one. Well, x plus 4, x equals negative 4 is going to be from this factor, and x equals a positive 2 from the last factor. There's our 3 solutions, 3 factors, or three solutions, 3 factors with an x, and a 3rd degree. Okay, not a coincidence at all. And if
So
we want to factor,
we don't have to worry about the 3 that we factored out.
no, because it doesn't have an x.
Yeah. Okay.
If you want to make a little graph, look, this section, it's not going to ask you to make a graph. But if you wanted to, just to kind of, excuse me, see what's going on. 1, 2, 3, 4. We got negative 4, negative 1/3, which is about right there, and a positive 2. And again, we've got a 3rd degree polynomial, positive. So that's going to go up here, down here. It goes up. Actually, it's going to go way up. And then it's going to go way down. And then way up. It looks something like that. This is just a rough sketch. Not perfect, rough sketch. Okay. I'm going to squeeze one more in, and I've got like 4 minutes. But I want to talk about this one because we're going to use the calculator a lot in the next class. So you need to bring the calculator to the next class, or if you watch these later, have the calculator handy. We're going to talk a lot about that TI-84, 83 calculator and all the fun stuff it can do. I want you to look at 50, number 50. And we've got this function 2x cubed plus 11x squared minus 7x minus 6 equals 0, okay? And what they did is they actually plugged this into the calculator. We're going to go over how to do that in the next class. But they plugged this into the calculator. And what's nice when you do that, it can give you a table of coordinates. And that's what number 50, if you've got the book open, number 50 gives you a table of coordinates. And the coordinate that matters for us is the x-intercept. So I want you to find on here the x-intercept. Because remember, the x-intercept is also a 0, which is also a solution, right? So if you go to that table, look, like the first coordinate's negative 360. The next coordinate's negative 236. Well, remember, if it's an x-intercept, y has to be 0. So if we go through here, y equals 0 at 1, 0. 1, 0 is our x-intercept on that, that, I forgot the word I'm going for. Lord, what's the word I'm going for? Oh, table, Jesus Christ. Okay, on that table, 1, 0 is the x-intercept. So what that tells me, though, is if 1, 0 is the x-intercept, x equals 1 is a solution. Okay? So on that table, we found that x equals 1, or 1, 0 is an x-intercept. Now, 0, like negative 6, is the y-intercept. That doesn't help us out at all. 1, 0 is the x-intercept, which means x equals negative 1 is a solution. I've got like 2 minutes, so I'm going to zoom through this. 1 is a solution. I'm going to factor it out. 2, 11, negative 7, negative 6, 2, 13, 13, 6, 6, 0. Okay? Hey, it does wind up being a solution. But what that also means is that f of x, now remember, if 1 is the solution, x minus 1 is the factor, right? Times 2x squared plus 13x plus 6. Now, this factors, that's 12, so 12 times 1. So winds up being 2x squared plus 12x plus 1x plus 6. I can factor a 2x out, and I'm left with x plus 6. I don't want to factor anything out. I know I'm zooming here, guys, but I don't have any time left. Hold on. This
I'm
factors
actually
in the
keeping up.
first. What's up?
I'm actually keeping up.
Hey! So we wind up with x minus 1 times x plus 6 times 2x plus 1. So our solutions are x equals 1 from this factor. We knew that because it was an x-intercept and it had a remainder of 0. The other two are going to be negative 6. 2x plus 1 equals 0. Subtract the 1, divide the 2, you wind up with negative 1/2. Okay, that's number 50. And you'll see one kind of like, you'll see that one on the test. So for homework today, start on page 374. Page 374. And it's going to be, I want you to do 17 through 49 odd. 17 through 49 odd. And listen, I'm not joking, I guess I should say. Joking is not the right word. But you've got to do this homework before you look at the 3.4 lecture. Before we go, you have to have this done first. 3.4 is not going to make any sense. And the way I teach 3.4, I assume you've done this already and you understand it. Okay. So I need you to get this homework done before Wednesday. And at the beginning of class on Wednesday, I'll go over any questions. Okay. But you have to have this homework done because really it's kind of the base to everything we're going to do in 3.4.